All right, guys, since I am not here this morning, this is the video going over the review that you did yesterday. We have a test tomorrow, so please, I'd like you to at least look this over, make sure you understand, because if you just copied off of the person next to you to get this done, that's not going to do you any good for the test. So please look this over at least once, either in class or tonight before you come back on Wednesday for the test. So we're talking about ordered pairs here. Which set does not represent a function? So remember, if it's a function, x will not repeat. So we want to find where x does repeat, so it is not a function. So I'm just focused on the x values. 4, 6, 7, 9, okay, that is a function. 0, 1, 2, 3, that's a function. -2, 0, 9, 8, that is a function. So it must be the last one here. 5, 6, 10, 5. So 5 repeats the x value. So this one is not a function. So that's how you look at ordered pairs. Here we have it in the mapping. Remember, the mapping is, I think Jackson called it the eggs. So we have the mapping here, and remember, it's just coordinate pairs this way. So we do not want x to repeat. So that has one arrow, one arrow, one arrow, one arrow, one arrow. So we are good. That is a function. Right here, one arrow, one arrow, one arrow, one arrow. One has two arrows going off of it. So this one is not a function. A is a function. And it says explain why. So the x value of 1 repeats. So that simple there. The x value of 1 repeats. Which graph represents a function? So here we're going to have to use the vertical line test. Remember, it's just a line up and down. So if it ever goes through a point more than once, it is not a function. So right here, it crosses twice. So not a function. This one looks like it would be fine. It's only going to go through 1 point. So this is a function. And it says explain why. So I would say it passes the vertical line test. Okay? Or you could say when you run a line through it, it only hits 1 point, but that kind of makes more sense and it's a little easier to maybe remember and write. Number 4, evaluate each function in the table at f of 3. So remember, you're going to plug this into Desmos, and if you want, you can just say y equals 3x plus 5. Not a big deal. And then you're going to pull up the table. That's that settings wheel. Looks like a little wheel. Click on that and pull the table up, and you're looking for the x value of 3. And I believe 3 times 3 is 9 plus 5. The answer, the y value, should be 14. And if you don't see 3, remember you can type it in. Just hit enter. All right, so then delete that one and plug this function into Desmos. And this should give you, pull the table up, it should give you a value of -4 as the y value. This is the x value. We're checking 3 each time on these. All right, and this one is the same thing as y equals 5, so it's always going to be 5s. And again, if you just plug that into Desmos, pull the table up, all the y values in the table should be equal to 5. And play with that. Make sure you understand how to do that before the test tomorrow. I can't show that on this video. Okay, number 5. Using the table, which function represents the height of a child each year on the child's birthday? There's a couple ways you can do this. Probably the easiest would be to plug this equation in to Desmos and then click on the table and see if this is the table that appears for these values. And then if it isn't, delete it and try that one, try that one, try that one. The other way, if you go back to 0, remember, so we have, rewrite it here, 5, 4, 3, 2, 1, 0. That is our starting point. So we had 120, 110, 100, 90, 80. And then you do reverse slope. So looks like we're going down by 10 each time. So this would be 70. So that's our starting point. So our function will be something plus 70. That's where, and then you put your slope next to the x, and we decided it was 10, right? Plus 10, so it's 10x plus 70. So that is answer B. So that might be the easier way to do it, but again, just plug each of those into Desmos and eliminate the ones that don't work. So that's how you can do it. You go backwards to the 0 right there. Okay, we're halfway through. Number 6. When May was born, her parents gave her 6 dolls to start her collection. Keyword there, start. That's her starting point. Each year she receives 4 new dolls as gifts. Write a function f of x that models the total number of dolls in her collection after x number of years. So 6 is the starting point, so it's going to be plus 6. And there's really no way to do this in Desmos. You just have to be able to read the word problem. 4 dolls every year. So that is going to be the change, right? The slope. So 4x. F of x equals 4x plus 6. Straightforward, fairly easy there. You get the 6, you get the 4 out of there. Okay, then we're going to graph each function. And again, you'll be allowed to use Desmos. So just plug this in, get the table. Don't just draw a line, because that's what it looked like. You need to get the table from Desmos to get the exact dots on here. I mean, it'll be on the Chromebook anyway. So, all right, this one is going to be -2 is my starting point. And the slope is 1 over 1. And again, you can get that from Desmos. So up 1 over 1, up 1 over 1. So it's going to keep going like that. And you would draw a line like so. And the second one, this is y equals 3. And again, use Desmos, but it's going to give you a line right there at y equals 3. So use Desmos. Don't try to make this harder than it needs to be. Starting point, again, use Desmos, but I know I can do it this way. Starting point is 4. We did a whole lesson on this. That's your y-intercept. So I'm intersecting my y at 4, and now that's my slope. And you need to make the negative either top or bottom. So I would put it on the top myself. So down 1 over 3, down 1 over 3, down 1 over 3. And again, Desmos will pull up a table for you where you don't even have to do this. But if you wanted to or know how to, that would be what it looks like. And pay attention to the fact that, remember, this is positive slope, so it should be going up. This is 0. There's no x in here, so it should be going just left and right horizontally. This has a negative in front of the slope, so it's going down. Okay, number 8. The function p of x equals 10x minus 300 models the total profit p when selling x tickets to a dance. The cost of the DJ is $300 and tickets will sell for $10 each. Drinks and snacks are being donated, so we don't have to worry about adding those into the cost. It's basically the DJ. So p of 0. This is another one. Plug this thing right here into Desmos. And then you're just pulling up the table and you're looking for 0 in x. Okay? And when that happens, the y is going to be -300. So in the table, it'll look something like that. And it'll have 1, 2, this would be negative 290, this would be negative 280. Okay, so what does that represent? Remember when you see the word represent, that's like putting it into words. So this isn't just 0 and negative 300. There's a situation going on here, a real life scenario. So what does the 0 mean? Well, that is selling tickets, right? The X. So when 0 tickets are sold, we lose, because it's negative, $300, right? If we have to pay the DJ $300 and nobody shows up for the dance, we're in the whole $300. So that's what that means. Find P of 30. You can use that same function all the way through this scenario here, number 8. But they want to know 30 as the X value. Well, 30 might not be in the table, so remember, just go to a blank square, type in 30 and hit enter, and over here should populate the answer to P of 30. I don't have that in front of me, so I think it is 0 though. 10 times 30 is 300 minus 300, yes. So that will give you a 0. So P of 30 equals 0. Again, what does that mean? So when we sell, if we sell 30 tickets, you could say we make $0 or we come out even. So even if we sell 30 tickets, we're not making any money because we had to pay for that DJ. So we have to sell more than 30 tickets to get a profit here. Find P of 115. Go into that same table, type in a 115 and see what you get there. And that should be minus 300. I think it comes out to be 850. So that is 850. And again, what does that represent? If we do this repetitively, so you get this for the test. If we sell 115 tickets, we profit or we make 800. So it's the first time in this situation that we've made money. We profit $850. So we need to sell a lot of tickets. If graphed, would this be a discrete or continuous function? So remember on the notes, I'm going to pull them out here if I can. Okay, maybe I won't. Discrete meant it was just dots. So like that, continuous would be a line. Now, if you plug that into Desmos, it's going to give you a line because it doesn't know the problem. But what it's saying is when it's continuous, you get every real number on there. So you get 0.2, 0.3, 0.5, 0.6, 7, 8, 9, everything in between whole numbers. So looking at this from a ticket standpoint, could I sell 0.2 or 0.4 or 0.7 tickets? No, you can't. You can only sell whole number tickets. So this would be like 1, 2, 3, 4, right at those dots. So this would be a discrete function. And explain why. I would say because you cannot sell partial tickets or pieces of tickets. What would be an appropriate domain? So there was one like this on that homework. Basically that's saying what would the X values be, the domain or the X values. So again, you would just want to say whole numbers. Whole numbers greater than 0 maybe. Because we couldn't have 0.2, 0.3, 0.4, and you couldn't sell negative tickets. So we have to either going to sell 0 or more than that. So whole numbers that are greater than 0. So that is the review. Look this over. You also have an additional review, hopefully you can do after this, and just knock it out of the park on Wednesday. All right, guys, have a good day.